Welcome to the Women in AI Research channel. I'm your host, Ekaterina, and I have recently returned from an incredible week at NeurIPS 2025 in San Diego. The conference is now over, but I am continuing to share all the most interesting insights, research highlights, and behind-the-scenes moments with you. Let's dive into today's NeurIPS highlights.
Well, on that topic, Yejin, one thing that was super interesting in your keynote today was how you're pushing the frontier of these small models. And can you say a little bit more about how to unlock even greater performance from smaller models?
Yeah, so we can sort of think about two broad ways of doing that. One is data. So long as you have a really good data, it can go quite far. Now the question is, what is good data? Whatever you find from internet, it's maybe good, but the thing is, it's not going to give you any advantage whatsoever compared to the frontier models that have already downloaded all of what you just downloaded. So this is where I get to think a lot about synthetic data, the power of synthetic data, especially synthetic data that's not even in the internet in any form, like something qualitatively different and ideally even better. So it's not easy to cook up that kind of synthetic data. This is where suddenly algorithms become relevant. The reason why I think a lot about algorithms is in the short term, because of the data. The better data you have, just models can learn so much faster. But in the longer term, I do believe that it's possible to have algorithmic innovations that can overcome the heavy dependence on the data, just like human brain. Human brain is a living example of this, low power learning mechanism that doesn't consume not that much of data compared to how much modern day generative AI does, yet able to generalize so much better. So I think, let's say in the far long term, I hope something like compute efficient, data efficient, solutions to be discovered. Medium term, I'm very excited about compute intensive ways of doing things that are data efficient. So in some sense, trading data with compute. I guess that's good for NVIDIA too. It so happens. But because I think we have to do this step by step. So in order to really go all the way, now the question is, how do we use more compute in order to do more data efficient learning?